There you are now. Welcome back to the workshop. So, I may have said in the last video that when you see this cylinder head again, it'll be back from the machine shop. But you know what? I got to thinking there's actually a couple of machining operations to be done, and it makes more sense to do them now before we send them to the machine shop. So, we have a cylinder head a thermostat housing stud broke off, but also this thermostat housing is really crusty, and trying to get a thermostat in there, get it to sit right and be a nice job is no good. So let's put the boring head into the milling machine and clean this up. Show you how I do that. Show you how I deal with a broken off stud like this, and then also I want to show you how it is that I block up one of the waterways, one of the original waterways that went to the water pump, the bypass they call it. So first thing to do is just going to zap this stud off flush with the cylinder head, and then we can center punch it, drill it out, tap it back to size, and then we'll set up for the boring operation. Okay, so we're getting that cleared up. Now, what we need to do here is we need to accurately center punch the middle of this. Now, this is something I've been doing for a while, so I can get this where I want it. If you don't get on center the first time with the punch, don't worry about that, because you can always walk your punch mark over just by angling your punch like that a little bit, and then eyeball it, and when you know you're dead on the center, you might go that way just a tiny little bit. Happy that. Okay, so we're dead on the center there. What we can do now is we can use the milling machine to drill nice and tight on center. You'll always see me doing this, lowering the head or highering the head. There is enough motion in the quill that I could have just brought the quill down, but the more you bring the quill out of the milling machine, the more play you can get. In a sort of machine like this, this is far from, you know, top of the line, but it's a good machine, and if you work within its tolerances, it can be accurate. One of its tolerances is the quill can get a significant amount of run out when it's far out from the machine. But when the quill is tight up in the machine and you keep the quill lock just barely jammed on, it'll do very well at drilling a tight cylindrical hole, I suppose is the right term. So we'll just plug it in, and what we have in the chuck at the moment is a center drill. The center drill is really stiff, and it'll allow us to get right exactly where we want. So just using our cross slides, we can get onto our center punch mark, which is right about there. Now, lock your cross slides. If you guys don't obviously have access to a milling machine, you might have a pillar drill. If you have a pillar drill, that's good. You know, you have to spend a bit more time setting the pillar drill up, but you're going to get the exact same benefits out of the pillar drill if you can get yourself a little bit of run out there. Let's bring that in. Alrighty. So we're just heading down through the center of that stud hole now, exactly the way we want. And we're going to chamfer it right out using the, okay, seen cast iron there. Yep. You'll see the cast iron straight away. You'll get this grey, very fine powder chip coming up, and that will tell you that you have gotten to the outer edges of the hole. The next thing to do is to go down through it with a starter drill. For anyone who doesn't know what size drill they should pick for threading, there's loads of drill threading charts on the internet. You can Google it, you put in what size fastener you're using, the pitch and the thread size, and it'll tell you the right size drill bit. But an old machinist taught me this trick 100 years ago, and it's been always very, very useful to me. And it simply said was, get a drill bit that when you turn it upside down fits tightly into your thread. So basically, when you turn your drill bit upside down, if it fits tightly into your thread, then that will tell you that's the right drill size for that hole. It was a quick trick they showed me, and it's worked for me. This one is only going to be the pilot. It's still not the right size. We need to go, we're going to need to go up a size, but we'll pilot the hole first with this, and then we'll go. It's always a good idea when you're drilling out a stud like that, don't go straight away for the biggest size drill or for the top size drill, because remember, what you're going to end up then with is only the threads left, only the threads of the bolt left, because the bolt threads are still going to be there. Now, what I'm actually doing here is I'm going to go from the UNC fastener that used to be in here to metric M8. I have loads of metric M8 studs made for these, and M8 will work brilliantly here because it's just ever so slightly bigger. It takes a 6.8 millimeter drill bit, which the drill bit size for the old UNC fastener would have been 6.2. So it's perfect. We can drill through with a 6.8. That gives us that slightly larger hole. It'll clean up this thread completely. We can put a fresh M8 thread into it and know this is perfectly fine. You could, in fairness, drill this and put a helicoil in it as well if you wanted. They work really well in this type of application, but to be honest with you, going to M8 here works perfectly well. I'll give the customer an M8 stud with this and he'll be able to fit and forget, and it'll solve his problem. So before we lock the cylinder head cross slide again, or sorry, the milling machine cross slide, we'll just center up on our bore, lock that, and we'll go through. Now, this drill bit is running a little bit too slow for this operation, so I'm going to have to take my time with it. Technically speaking, I should be running this drill bit probably at about 700 or 800 RPM, but rather than changing the speeds continuously on the milling machine, I just take my time, follow down my trace, and drill out my hole. Backing out the chuck every now and then just to clear off those chips. And you can see we're through the bolt now and we're into cast iron. We're going to just make that hole slightly deeper so that we get nice new fresh threads and nice new fresh cast iron. Okay, so that is our final size drill. So that for metric was 6.8. Next thing I'm going to do is I'm going to put this M8 starter tap in the chuck. Now, I am going to attempt to power tap this. I could, but there's no need. A little bit of oil on the threads here of the tap and die, the tap. And then I'm just going to feed this by hand. So, as I said, I could power tap this, but I'm not going to even attempt because such a small tap and with such power in this machine, I could easily find myself running into trouble. So rather than try and power tap it, what I'll do is I'll get it started with this starter tap. Plenty of oil in there. Now, two reasons why. There'll be bits of the old bolt here, so this won't be a clean threaded hole that I would have had if it was a fresh hole that I was drilling, and in that case I could power tap it. But in this case, what I want to feel is when I'm picking up bits of the thread of that other bolt. Once I've gotten in a little bit of the way here with this tap, and I'm happy that I've got some square threads to go on, I'll go with a manual tap and T-wrench, and I will be able to tap this by hand then all the way to full depth. And then the only other thing we'll need to do then is to countersink the holes. So we've gotten in there a little bit of the way now with that taper tap, and I'll show you the difference now between a taper tap and a finishing tap. So in the tap wrench here, I've got a plug tap set up. And a plug tap basically has very little taper on it, okay? It's just a small bit of starter. So if you look at the tapered tap that's in there at the moment, it has a really long taper for starting a tread, whereas this one has a really short taper, and it's designed to continue a tread all the way to the bottom of a hole that you have tapped. So we can get this one started on the treads that we've put in there, nice and gentle to make sure we pick up the treads that we've already got in there. And I can already feel us starting to pick up a few little bits of that bolt. Now, another way you can do this is with a spring center. If you've got taps that work with a spring center, what will happen is you will be able to, there we go, now we're picking up, there's the treads that we started with the taper. So it's important just to take your time with it, just to pick up those treads that we started. So I'm in the treads now that I made here, and what we were cleaning out there at the start, because we've gone from a taper tap to a plug tap, we were cleaning out the remnants of the old bolt that was in there, and taking your time at that makes for a very worthwhile finished result. So going half a turn forward and a quarter turn back just to break off the chips and to make sure that we're cleaning our tread, and we're working our way then to full depth. And what we're going to end up here with is a perfect finished stud hole for the customer, and I can feel now that I'm reaching the base of that hole, which is exactly what I want. And when we get to full depth, we'll back the tap out, take your time at the very end there, just to make sure that you don't cross the tread tap coming back up and out. And we'll inspect those treads, and they are absolutely beautiful. Really happy with those. Just try an M8 bolt in it now just to be sure. There's an M8 bolt, and you can see that's spinning in by hand, and there's no play in that bolt. That has a really good anchor in its tread. So very happy with that for a finished result. The customer is going to be delighted with that. The only thing that I want to do now, just to finish this little process up, is I'm going to just put a countersink on the top of that threaded hole, just so that when the gasket is put in place, that we don't end up with picking up and while we're here, we'll do the other ones. Okay, so we've the countersinks done on the other two, and I've just filed up the surface just to bring it back up again. So we have a really nice gasket surface there, nice and flat, and 3 good holes. The next thing to do is to bring down the sort of crustacean that's around here, rust and pitting. And the best way to do that is with a milling cutter, with a boring head. So this is a cylindrical boring head that I have in the milling machine, and I've centered it up very close to the center of the thermostat housing, and we're just going to take a couple of light passes. We're not going to increase the diameter at all, but we're just going to bring up a nice smooth machine surface for the thermostat housing to sit into. At the moment, if we put a thermostat housing in it now, it'll sit proud of the surface of the cylinder head, which is no good because it'll hold up the thermostat housing, which could create a leak. So to give this customer the best possible chance at a good quality seal here, we'll bring this in. So I'm running the cutter quite slow, and again I'm doing that for 2 reasons. One, because we've got quite an offset and a long bar, and secondly, the idea is just we're going to take our time, take a couple of passes here and get a real nice finish. So feed the cutter down nice and slowly, and what's going to happen is it's going to pick up that bore And very shortly now we should start to see blow away those chips. Brilliant. Okay, we'll get Billy to come in there nice and close now, and you'll see that finished surface. So what we have now is we've got that real nice clean square edge all the way around, nice flat surface there for the thermostat housing to sit on, and we've restored that gasket surface now back the way it should be, so that we have that bolt hole where it'll pick up again. We've brought it back that surface for the gasket to seal on, and we've brought back that surface for the thermostat to sit on. Last operation before we can finally send this cylinder head off to the machine shop. People say, how come it takes so long to get a cylinder head back? These are the kind of lengths that we have to go to get them right for you. So last thing to do is to flip this head over. I'm going to show you how we bung up this bypass. Before I do that, just want to say thank you very much for watching the videos. Thank you very much for all your patience. As I said, I know the videos aren't coming quite as regular as they used to be, but as I said, I'm just trying to get you guys good content. If you do like the content, hit that like button. It really does help us. I love reading your comments in the comment section below. I may not reply to every single one of them, but I do try and read all of them. So thank you very much for that. And comment away. Any questions that you have, put them down there and I'll try and answer them as best as I can. Also, don't forget, if you're new to the channel, you are most welcome. We love having you along here in the garage with us. We've got a lovely little community of people building up here. We hang out here in the garage. You guys get to follow my escapades with engines, machining, cars and whatnot, and I love having you along for the ride with me. So don't forget to hit subscribe to learn about our new content as it's released and when it's released. Right, let's get straight back into this and get this cylinder head finished. Okay, I've the cylinder head flipped over, and what you can see here is this here is where there used to be a bypass. So bypass, should I say. On a lot of the earlier cylinder heads, this bypass went to a connection on the water pump. And the idea was if the thermostat was closed, water would still flow between the cylinder head and the engine block through this bypass until such a time as the engine temperature got up to open the thermostat, and then the thermostat would open and it would flow. The simpler way of doing that is actually just to drill 3 or 4 small holes in the thermostat housing and do away with this setup, because what this inevitably leads to is the hose between the water pump and this gets hot and cold, hot and cold, hot and cold with the engine running, and eventually fails. So I've advised the customer that we're going to, rather than fit another bypass, we're going to blank this off with a M14 grub screw, and he then can buy a blanked off water pump like they use on the later cars and a drilled thermostat, and then his problem will be solved. Now, for people that absolutely wanted to retain the originality of their engine, then it is possible for us to make a sleeve up, machine a thread on the end of it, drill this out and put a new sleeve in there that would act as a hose barb to retain the bypass. So that is possible, but this customer just wants a reliable Mini that's going to work for him, and this is probably a good way of ensuring better reliability. So milling machine running nice and slow. It's cast iron, so there's no need for any kind of lubrication. Just bring the drill bit down, nice and handy. We're going to drill straight to tap size here, which is 12.8. Because we're running M14, so we're just going to go straight to the correct tap size. Again, taking it nice and handy here. We're drilling out the old hose, getting to cast iron. You can see the cast iron dust here around the edges, which is what we want. That's us through. exactly what we want. Next step now is to do like we did before with our tap. So same thing again, we'll start the tap in the drill. So we'll put the tap into the chuck. We'll let it start it, but because this is M14, there's no way we could power tap it or even tap it by hand in this drill chuck. So we'll just literally get the tap started. And then once we have a start, we'll tap it by hand then. Now the plan here is I actually don't want to tap all the way to the full depth that this hole goes. I want to actually leave the tread a little bit shy, and the idea will be that when I put a little bit of tread lock on that M14 fastener, it'll actually bind up in the end of the tread, and that will give me a good fixation, a good lock for the tread. So just give this another couple of turns here just to get this tap started so that we know we're tapping parallel. We're just using the inertia of the machine here, just rolling it back a quarter, running it in a half. And the tap will slip in the chuck if it gets too tight, which is actually a good thing for us. And we'll just have to finish this by hand now. Loosen that off. Let's put the head of the milling machine out of the way. It's just about taking your time and working your way down. I'm checking continuously to make sure I'm not going to break through. I'm going to go another small little bit with that and get about another probably 2 threads there, and then we can test fit one of our bungs to see how that fits, and that is exactly what I want. So you can see that it's sitting just proud, a thread or thread and a half just proud above the top. That means when we put a little bit of Loctite on there, we can wind that in, we'll get an interference at the base of the thread, and it will seal that perfectly for us. So let's just blow out that thread. Use my safety hand. Get a little bit of Loctite. That's the stuff we want. You'll notice that these have rust on them, or a hint of rust on them. That's on purpose. I've washed the coating that would be on them normally off. There'll be a coating on those normally, which is a kind of an oily, greasy coating. And for the purposes of Loctite sealing and working in an application like this, you absolutely don't want any kind of oil or grease getting on there. So for us, we want to apply that. Now, in a situation like this, I always like just to give it an extra little bit in here. This is never coming back out again, so for us, being absolutely sure that we get a good seal in there is imperative. And we're getting into that lovely thread bind situation, and that's exactly what we want. That guy is locked in there. Blow away that excess Loctite, and that's it. We've affixed a great repair here. That is completely sealed. When this cylinder head goes back together, we'll have no leaks here. Customer will be guaranteed of reliability there again. Finally, that cylinder head now is definitely ready to go off to the machine shop. There's not a single other job we can do. So we will get that off to the machine shop, get the valve seats cut, then get the head back here to the workshop, and I'll show you the final process, which is fitting the valves, checking the valve spring seat heights to make sure that we don't need some shims or to add shims for our seat pressure loads, and then that cylinder head will be ready for the customer to come and collect, and we'll get on to our next project here in the workshop. Thanks for watching. See you on the next one.